Hello everyone, welcome to Tutor online platform. We thank all of our subscribers, and if you have not subscribed, kindly click on the subscription button now and then the notification button so that you can get notification whenever we post new videos. Today we want to talk about a very interesting topic: integration by parts. Integration by parts. This is also the same way we integrate two functions when they are multiplying themselves. Whenever we have two functions multiplying themselves, we have to come back to use integration by parts. So I will make this as the example: integral of x e raised to the power x dx. But before then, I want to show us how we got the formula for integration by parts. So the formula for integration by part was actually gotten from the formula of product rule from differentiation. So if you remember product rule, if you differentiate two functions multiplying themselves in product rule, you are going to have the first one differentiate the second, then you have it plus the second one differentiate the first. So we want to have something like this for our integration. So the first thing is to integrate each term. Integrate each term. Integrate each term. And what are we saying? We are saying do the integral of d of uv, which is equal to the integral of u dv plus integral of v du. So looking at this, if you integrate duv, you're definitely going to get uv. Okay, it's just like when you integrate the x, you're going to get x. So the same way when you integrate uv, you're going to get, and duv, you're going to get uv, and then you have integral of u dv plus integral of v du. Okay, so at this point, we need to make one of these two the subject of formula. So I'm choosing this one. So you have integral of u dv is equal to uv minus integral of v du. So this is what we know as the formula for our integration by parts. Integration by parts. So follow me gently as I try to use this formula to solve this question. So in this question, we have integral of x e raised to the power of x dx, and at this point, I'm going to divide the this particular integral into two parts. I have x standing alone, and I have e raised to the power x dx standing alone. So I want to make use of this formula. Don't forget, we have the integral of u dv is equal to uv minus integral of v du. So at this point, I want to say that let u be equal to x. Basically, before I go on, I have to explain this, that there is an acronym to the way we choose our x. We don't just choose our u. We don't just choose the u anyhow. So there is an acronym that says ILATE. ILATE. So we follow this from top to bottom. It comes up down. So we check, the first thing we check for is if we have an inverse function in the two functions multiplying themselves, because I is standing for inverse, L is standing for logarithmic, that is logarithmic functions, A is standing for algebraic function, T is standing for trigonometric function, while E is standing for exponential function. So what we check for is, the first thing we check is, do we have an inverse function in the product? No. The second thing we check, do we have logarithmic? So if we have inverse, I would have chosen my u to be the inverse function, while the other function will be my dv. But because there is no inverse function, we check again, do we have logarithmic function? No. Do we have algebraic function? Yes, x is an algebraic function. And mind you, e raised to the power x is an exponential function, which is the last on the list. Okay, so because my x is the algebraic function and I can see it here, I pick it as u, and then the other one, which is the v, is going to be e raised to the power of x dx. Alright, so you may have to watch the video over again to be able to understand what I'm really saying. Then I come back to this because I know that in what I have here, I need u. I have u already. I need v. I don't have v yet. So to get v, I can integrate both sides. If I integrate both sides here, I have v is equal to, if you integrate e raised to the power of x, what you do when you integrate e raised to the power of x is to differentiate the power. You write e raised power of x normally, or whatever you have, whether it is raised power of 2x, 3x, or whatever. Then you differentiate the power. The derivative of x is 1, then you divide it with it. So that is e raised power of x over 1. So integral of e raised power x is still going to give us e raised power of x. So we don't need to write dx again because this integral would have taken away dx. So you have your v to be equal to e raised power of x. U is out, v is out. But we need du. We already know what u is, we already know what v is. So we need du. So you come back here to differentiate both sides, or just say du dx, because you can only differentiate with respect to x. So I will just have to say that I want you to note that if I write du, it's still the same thing as saying du dx. So at this point, I want to write it as du dx is equal to 1. Du dx is equal to 1. So I can cross multiply to have du is equal to dx. So now I have everything that I need to solve the question. So I go back to my integration by parts. So integral of u dv, which is the same thing as x e raised power of x dx, is equal to uv. What is my u? My u is x multiplied by v e raised power of x minus integral of v du. V is e raised power of x. And what is my du? My du is the same thing as dx. So you have dx. Alright, so I would like to continue on this side. So I'm going to be having, let me just write it again here, integral of x e raised power of x dx is equal to x multiplied by e raised power of x minus integral of e raised power of x dx. So you're going to be having, if you multiply these two together, you have x e raised power of x minus, then if you find the integral of e raised power of x dx, you get e raised power of x. So you can also add the constants of integration to it. So this is the answer when we integrate x e raised power of x. I hope you've been able to learn one or two things from this video. Don't forget, you have to click on the like button so that our videos can pop up each time you get to Facebook or YouTube. And don't forget to click on the subscription button. Thank you very much. See you next time. Bye.